Okay, now we're going to talk about graphing log graphs. And the parent graph is just log y is equal, or f of x is equal log base 10 of x. And the parent graph for the base e is just ln. Its invisible base is e. For log log, the invisible parent function, the invisible base 10. Okay, so let's start with showing you this one. This is what the parent graph looks like. Notice with exponential graphs, there was a horizontal asymptote, and now remember logs and exponentials are inverses. The inverse of horizontal asymptote is vertical asymptote. So e to the x has a horizontal, or 2 to the x, and log of x has a vertical, right? So that's a visual way that you can see that those two things are inverses of each other. And then notice right here, there's a solid point at 1, 0. It's because if you type any base, doesn't have to be 10, but if you type right now on the calculator, if you hit log 1 close parentheses enter, you get 0. So at 1, 0, that's always a starting point on log and natural log. Okay, so that's what the parent graph, just like this, it takes all the way till you get out to here before you hit a height of 1. So if you type in log 10, and the reason that's 1 is whenever the base number and the argument number agree, the answer will be 1. You'll be at a height of 1. Okay, so now you're going to do what we've been doing for a long time. You're going to notice whatever's on the outside, and that tells you to move everything up 1, 2, 3. So now we're there. Okay. And then remember, on the inside, you do the opposite. So you're going to move everything back 4. That includes the asymptote. So the asymptote gets moved to -4. And now this right there, 1, 2, 3, 4. This dot, I should move that up. And then 1, 2, 3, 4. And it would have looked about something like that. And then you need to find the domain and range. Okay, so notice the domain on this. It doesn't go anywhere to the left of that asymptote, and we can't even touch at -4. So the domain, it starts at -4, but it gets an open parentheses, and then the graph, so it starts not touching, it starts here, and it infinitely goes there. But now look at what we have for the range. We didn't talk about domain and range for exponentials. I need to make sure I cover that. Well, even though it's starting down here at -infinity, as it goes up, it turns, but it's still infinitely going up. And infinitely up means positive infinity. So for logarithms, the domain is whatever zeroes out the argument to positive infinity, and then the range will always be, so 4 logs, this is what the domain for exponentials, for b to the x or e to the x, whatever number is out here being added, that's the range, right? Wherever this horizontal asymptote is, it starts there and goes up, right? So for this one, the range is whatever this is the d value. The d value is to positive infinity. And then the domain, even though we're going, it looks like straight up, but as we're going straight up, we're still headed that direction as we go up. So for exponentials, the domain is negative infinity to positive infinity. All right, I kind of digress there for a little bit. Let me see. Hopefully I didn't erase everything underneath. Hopefully I locked that. All right, so remember what this parent graph would have been. The parent graph would have started here, and then it would have come up. The only difference is E, if you type in second ln, it gives you e to the caret type 1 and hit enter, you're going to get about 2.718. So at 2.718, so if you type ln of e and then put an e in there, so right here where e is at about 2.718, you're going to be at a height of 1. So this graph just rises. Remember what this one was? It wasn't until we got all the way over here. So this one doesn't rise as quickly. This one just rises a little bit more quickly. And there is no number there, so we don't have to worry about going up or down. But what's the opposite of negative 1? Positive 1. So we're going to move this over 1 and move this over 1. And now our domain, we moved it over to positive 1. And our range will always be, for logarithmics, is negative infinity to positive infinity. All right, that's graphing logarithm graphs, whether it's base E or some other base. We just did the invisible base 10. All right, that's it for this one.